Hey John, I'm going to make this super quick tutorial for you on how to make a bouncy ball. So in here is Unreal Editor. I hope you know the basics of navigating your camera and playing with all this stuff. I hope your editor layout kind of looks like this when you first start out. I think it was something like this anyway. But anyway, so I'm going to move a few things around just so, because the way that I'm used to navigating it. I'm going to move the content browser. All you got to do is just grab this little top folder doohickey thingy. Pull it up to the side here. That way it's just easier for me to see the list layout. If you wanted to see, if it looks only like this, all you got to do is press Show Hide Source Panels, and it shows all this stuff right here. Alright, so let's quickly go through how to make a bouncy ball. I'll go through this super duper quickly. That way it's just like super easy to get a hold of things. I'm going to create a new folder, call it Blueprints. In that folder, I'm going to create another subfolder called Bouncy Ball. Just for, bouncy underscore ball. Yeah, that works. Alright. That way it's just keeping the stuff nice, neat, and organized. Alright, so the next thing I'm going to do is right-click on this folder and then create blueprint class. So I'm creating a new class that's just like, blueprints are like a common class that is kind of defining anything and everything inside of the game that can be either referenced by code, by like pretty much anything in terms of like this high-level coding, which is the visual scripting language called Blueprint, but you probably already went through a little bit of that. But anyway, so let's go through this quick. I'm creating an actor. Don't worry about any of these other ones. The only thing that you really need to care about things that are not either player controlled or anything like that is an actor. So let's create an actor. So just for namesake, I'm going to call it BP for Blueprint and call it Bouncy Ball. So I know I created an underscore there versus not underscore there. Whatever. I'm just going through this quick. All right. After that, open it up. Double click. Open it up. You can maximize this. Doesn't matter. Right here, you'll start out with like this kind of an actor. This is a blank actor. It has some basic kind of commands. Don't worry about these. I'm going to delete them in the event graph. So all you got to do is just go in there and delete them. We'll get into that stuff way later. So that stuff's a lot more complicated if you want to get into that stuff. Don't worry about the construction script. You don't need to worry about any of that right now. To make a bouncy ball, it's super easy, super quick. So the first thing that you're going to need in order to have it register to the physics engine is something that talks to collision. And what, besides going into like the 3D assets, let's create a simple primitive. So what you want to do is actually go into add component here, scroll down, find one of the collision primitives, box, capsule, sphere. Sphere is definitely the cheapest inside of physics engines. The reason for that is just selecting a point, and then it has like a vector to a particular location, but that is more complicated than it needs to be. We're creating a ball, so let's create a ball, so it's a sphere. Okay, in order to have it register with the physics engine, this is what I've found out over long periods of time of creating different assets. The actor root position, root component, needs to be a collision asset, right? And you don't need to name it collision anything, but I like to. This is just naming convention. Root underscore sphere collision. Cool. All right. Next thing we're going to need, because right now this is just a collision volume and you won't see this in game. So you need something for it to be visible so that you can see it. So let's take, one of the components here just called sphere. This is a simple brush that is provided with the base of Unreal Engine. So you can grab that. Now, what you're going to want to do in order to make this thing work properly, because you can see here in wireframe that my collision sphere is actually smaller than my visible sphere. So I'm going to go back to lit here. How big is this thing? I think this is like a meter radius, or half a meter radius, so a meter diameter. So let's go into our root collision sphere up at the top left here, and then you go all the way to the right where you see details. You see sphere radius. I'm just going to make this 100 units. Okay, so this ball is actually much smaller than I thought it was. All right, so I think it's actually, the radius is 50. That actually looks about right, is it? I think it is. Yeah, that actually matches, like, pretty close, actually. It's pretty much there. If you want to buff it out a bit just so that you can see it, you can do, like, 52 just to see it. There you go. That's a little bit better. So the thing with this is you might notice that, it might be floating off the ground. But if you want to make it, like, exactly flush, I think it's actually 50. So yeah, we'll make it exactly flush. So you can kind of see it there. Alright, so with that said and done, we can compile this, and that should be totally fine. Everything else, this is all stuff that, we can play with later, but I guess the main physics stuff is, since we're wanting to make this thing a bouncy ball, we can have, like, the enable gravity on this thing, and it will bounce. So this is very, very simple. Linear dampening, all this means is as it travels through the air, it'll slowly reduce its movement, and also it will enable it to eventually stop. So we can actually, like, turn that to 0 if we want this to be a frictionless ball, which is physically impossible unless you're in space and you're not being stopped by particulate matter or whatever. But that's a way to actually fake the thing that's actually it going to be eventually stopped as it bounces around. I don't believe we... Oh, wait. Yes. So, yes, root collision. I think this is all going to need to be actually on... This is just a collision preset, so we're going to have to make sure that this thing actually interacts with the physical world. So right now we're actually going to create this thing to block all, so in that way it can actually interact with world static. World static is like any geometry that's labeled as like a static object and will be immovable. That's the only thing that we really, really care about at this moment. So we can create, like, go into custom and actually change all these flags as we determine them. But right now, we're going to maintain a making sure that this thing is set to block all. Collision is enabled. Query and physics. Physics is the one that we need. Query is like a line trace thing, and that's way more complicated than this needs to be. So we're going to avoid that. So basically all we really did, I zoomed in here. We created a root collision sphere, so this thing can drive the object. That root object needs to have a collision in order to define where it is in the world space, and then therefore when the physics engine takes over, it will determine its velocity and acceleration and all that stuff, which is great. Attached to that, we actually attach the sphere. Actually, what I'm going to do... Yes, so this is something that we want to kind of look at as well. I don't know if the base sphere static mesh... Oh, yeah, I don't open it that way. Okay. If you want to actually find out, like, individual things about, like, different assets and go into them in the content browser, you can click on this little magnifying glass here, and then double click the sphere itself. I am going to check to see what kind of collision it has, and actually it has, it has obviously complex collision because it has triangles. So this is more complicated than it needs to be, but essentially anything that actually has, like, a render mesh to it, it can have what's called a complex collision. This is something when you have the difference between simple collision, when you have, like, a lot of interaction on the physics engine. It gets really heavy if you have something that has, like, a lot of triangles and it's constantly, like, interacting with the terrain or whatever. It will very, very much slow down the process of calculating all of the physics related to that object. So the best thing to do is actually create, like, a simple collision for the thing, and we kind of did that already with actually creating this root collision sphere. So we kind of did that already, other than we could go through this method where we're actually creating a simplified sphere collision on this thing, but I'm not going to do that now. This is actually more of a straightforward approach of creating a root collision sphere. That way you can reference that later if you want to, rather than actually having this static mesh as the specific object. But anyway, so this is more explanation than you need to at this moment. But all right, we'll go back to this. So my personal takeaway is I like to handle every individual component and every individual thing separately, because if you start expanding on creating this actor into like a baseline class for like a bunch of different things, like a projectile, you're going to want to change like how that sphere collision or how that thing actually looks compared to how it's going to interact with the environment, right? So let's say, for instance, this bouncy ball like is a projectile or a grenade or whatever that you're going to throw it, and it's going to have like a different collision. It's going to have a different kind of setup as you carry forward with that. But one thing, again, to keep in mind is your root component needs to have physical interaction with the world. Otherwise, it will not define its velocity and interact with the physics engine properly. All right, so I don't believe I need to do anything more. The should hit events, I don't think this is necessary yet, not until we're wanting to actually do blueprint thingamabobbers. So I am going to take this guy right here. I'm going to browse back to this asset, back to my content browser so you can see it here. And now with my bouncy ball, here, I'm just going to move this out of the way, so it's just going to go to the other screen for now. I can click and drag the bouncy ball, and holy moly, there it is. Let's also change its color, because I don't like the straight white. I don't know if there's any... Oh yeah, look at that. Basic asset. Let's turn this guy red. Sure, that works. Alright, save. Done. Hey, look at that. It updated all of my bouncy balls in all of my levels, and then it updated the thumbnail that's in the content browser. Great. Alright, so I am going to quickly jump into a game. Right now, this guy is not falling. So, there is something wrong with this guy that I need to change real fast, and I don't remember where... Yeah, there it is. So, the reason why it's not actually moving, of course, is it's not simulating physics. And like I said, the root collision sphere, or the root object, is the main one that needs to have this turned on in order for it to interact with it. You can read the tooltip there. If it's false, it will be fixed into the environment, therefore static. But you can set this up so then that way it will act as a physics object. So let's compile that, move that aside, press play. Hey, look at that! The ball bounces. Oh my god. So this thing has some mass as well. I'm actually shooting it with like kind of the prefab stuff that I have here. So if we wanted to play around with this thing, what we can do is modify the mass, make sure that, you know, this actually automatically calculates, you know, a volume of this thing. I think it has like some specific formula based on like the physical material and like the volume of the particular thing. So it has like an automatic calculation, and you can change all that stuff down in here for like a physics override. So yeah, I think they actually have, hey, look at that, physics matte rubber. I've never actually played with a lot of these, so we're gonna have some fun in seeing exactly what these do. So I'm gonna, hold on, browse to this asset. And this is a engine created physics rubber asset. So I'm gonna double click and just open it up here. All right, cool. So you can actually define on the kind of individual assets, like what kind of physical material it's made out of, and then this will interact with the physics engine accordingly, right? So it'll create like some additional friction. You can, what else does it do? Restitution, or bounciness of the surface. 0 is between no bounce, and 1 outgoing velocity is the same as incoming. I don't know if I can go higher than that. So hold on, let's make that 0. I want to see exactly what this does. Maybe this will be like a flat. Oh, actually, hold on. I need to. I don't think I can actually save this because this is a engine asset. So I will need to duplicate this guy. So physics matte, yeah, rubber 1, sure. And I want to move you into a different category. So I'm going to move you here. That way I'm not screwing up with the engine materials. And we are going to use the ones that we want to use instead. So I'm going to apply the rubber one. Applying my rubber to my bouncy ball. Alright, let's go back to my bouncy ball. Let's see what this does. Alright. I don't think that really changed it and its bounciness. Yeah. Do I need to generate hit events in order for this to turn on? Maybe not. Doesn't look like it's doing what I want. But that's okay. Alright, I'm going to turn on restitution to 500. Oh, it maxes out at 1. Okay. Yeah, so this isn't doing what I want it to do. I might just cut this section out. Alright, hey John, we're back. Alright, so, I don't know why it wasn't initializing first, but here, I will jump and show you now. So, alright, it is what I thought it was with the physics mat and setting up the rubber. So, setting up the restitution, setting it up fully to 1. I also made some tweaks about the mass of this thing, but it all kind of works anyway. So here, you need to do a physics mat override on this thing in order to provide it with, pull this over so you can see both. Restitution means how much bounciness it will have. Apparently, I guess there's a limitation on how fast this thing can be a pancake on the ground versus it trying to bounce itself. So even when I do restitution even at 0, it looks like there's still a slight bounce to the ball, as you can see there. But if you then change this thing to a value of 1, I tried setting this to randomly super high, but it is restricted in the physics on that, and I might dig into that to see if I can't make a thing that bounces more than the input actually given. And since there is gravity will constantly pull things down, and it will cause if you have maximum bounciness to this thing, it will cause each subsequent bounce to be half of what it used to be for those, just for a simple calculation. So you can see here, I now have a beach ball that I'm shooting and kicking around. Look at that. Woo! There it goes. Bounce, 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 bounce. And that's all you really need to do to make a bouncy ball. Alright, cool. That is all.